Completing the square. Introduction. What completing the square process is it is another way to solve quadratic equations. So let's quickly review the methods that we already know to solving quadratic or degree 2 equations. Remember, these equations typically look like this up here in standard form: ax squared plus bx plus c equals 0. At this point, we already know 3 methods to solving this equation. The first method is the factoring method, and that method works as long as your equation factors. The second method is the square root method. Remember, this method works if we are missing this bx term, only if we have the ax squared and the c term. And the last method that we already know is the quadratic formula. The quadratic formula method will always work if it is a degree 2 or a quadratic equation. And that formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. And if you have a hard time remembering that formula, I suggest you sing it to Pop Goes the Weasel. What this video is over is a fourth method to solving quadratic equations, which is called completing the square. Now, completing the square is my least favorite method in solving quadratic equations. And up until this point, we have been perfectly fine with solving the equations using one of these 3 other methods. So, I am not necessarily teaching you the complete the square method to help you in solving quadratic equations, but the reason that I am teaching it to you at this point is because it's going to help us with other things later in the semester, such as graphing quadratic equations, and it's going to help you in other classes. You will need to know the completing the square process in your trigonometry class if you have to take one of those. Before we actually get into the process, let us do some baby steps along the way. So our first baby step here is, given these 3 trinomials, we want to try and factor them completely. Now, we have done factoring many times before, so I suggest that you pause the video and see if you can factor each of these completely. Okay, example 1, as well as all of the examples here. We should first and always check to see if there's any common factors involved, and there isn't. There isn't in example 1, 2, or 3, so I'm going to go ahead and skip that step. Our next step is, we already know that these are trinomials because they have 3 terms. So our job is to unfoil them by setting up our 2 sets of parentheses. Okay. If we look at our first piece, x squared, we have to figure out what times what gives us that. We really only have one choice. This is going to be x times x. Now we typically jump to our last term of 25, and we try and figure out what times what will give us that 25. We have a couple of options, 1 times 25, or I always like to start with the ones that are closest together, which is 5 times 5. Our outside here will give us a 5x. Our inside here will give us a 5x. And we want to be able to add these to give us our middle term here of a positive 10x. And that will work if both of our signs are positive. So the signs in both of these parentheses are addition. Now we have factored this by unfoiling, but we have not factored completely. If we looked at our parentheses, we should notice that they are exactly the same. So this gives us x plus 5 quantity squared. And that is our answer to factoring this trinomial completely. Example 2. If you have not already, pause the video and see if you can factor it completely on your own. Alright, I already said there's no common factor, and it is a trinomial, so we will start it by setting up our two sets of parentheses. We need something times something to give us t squared here up front, and that gives us t times t. Then we need something times something to give us our 9 here at the last. We have choices of 1 and 9. Or, I always like to start with the ones that are closest together, 3 times 3. Our outside is a 3t, our inside is a 3t, and we are looking for something that adds or subtracts together to give us this negative 16 here. And that will work if both of our signs are negative. So we need to put a negative in both of our parentheses. We notice again that those are identical, so our factored completely is t minus 3 quantity squared. Example number 3. If you have not tried it on your own, go ahead and pause it and try it on your own here. No common factor. It is a trinomial, so we start with our parentheses. We need something times something to give us p squared, and that comes from p times t. Then we need something times something to give us 49. We have a couple of choices, starting with the ones that are closest together, is 7 times 7. Our outside gives us a 7p, our inside gives us a 7p, and to add or subtract those together to give us our middle term of negative 14p, what we will need to do is make those both negative. Again, they are identical, so these are p minus 7 quantity squared. And that is our final answer to factoring that problem completely. Now notice in the instructions here it said perfect square trinomial. So it makes sense that these come down to something quantity squared. Also, if you think of the name of the process that we are using, completing the square, it makes sense to come down to something quantity squared. So what our job is going to be in the completing the square process is to set up our own perfect square trinomial. What they will do is they will give you the first two variable terms, and our job is to come up with this constant term on our own. So let's think about how we can come up with that. I have started with the same exact trinomials here, but I've tried to identify some key factors. So what we want to do is we want to identify our own pattern to coming up with that constant term so we can complete the square. Notice that each of these are set up in standard forms that looks like ax squared plus bx plus c. So to come up with our own constants here, these all kind of follow the same pattern. They all start with the b term. So we take our b term and we try and figure out how we get from there to what we factored as here. Well, in each of these places, our b term, if we just divided by 2 or halved it, we would notice that we would come up with those numbers there. So that's the first start to come up with our constant term that's circled in blue, is we take 1/2 times our b term. From there, that factored as a quantity squared. Well, if we figured out how we got from here to here is, notice we would just actually square those. And it wouldn't matter if you included the positive or the negative with it, because remember, whenever you square something, it always cancels it out. So to get from our start of our b term to the ending of our c term, we take 1/2 b and then we squared it. So let's prove this again using the first example. If it would have started out as x squared plus 10x plus a blank, and if we needed to fill in the blank, what we would do is we would take 1/2 of our b term, remember the b is the one in front of the x, so the 1/2 times our 10 terms, and then we would square it. 1/2 times 10 gives us 5, and 5 squared gives us 25. So that tells us what we would fill in the blank with. And notice that is the same answer that it was started as up here. If we can fill in the blank with the appropriate term, then we can factor it as something quantity squared. And that is the next step in our completing the square process. That is where I'm going to stop this video. In the next video, we're going to find the constant term and set up our completing the square.